Welcome guys, welcome to another video. Oh, I gotta erase this first. So my friend Despacito told me I make too many videos, so I decided to do one more, and this is going to cover a good point. One of the subscribers mentioned about point of contact. That I also should kind of clarify what that is, because it's a massively important issue when it comes to the machining. If you've been machining for a while, probably this is not a video for you, but if you're a newbie, this is, like I said, for your safety and others. I think this is kind of pretty important to understand. It's a common sense, but sometimes, what do? We don't use the common sense. So the topic is technically point of contact. Okay, so when it comes to point of contact, the first thing that comes to my mind is this is a bad guy. Okay, I don't know how I'm gonna do this. I'm gonna give this a beard because that is Chuck Norris, and he kicks this guy right in the nuts. This is a point of contact. But seriously, I got your attention, I hope. So point of contact is that if you're gonna look at the jaw, right? So let's say this is your jaw. Okay, let's give it a nice angle right here. I'm getting better with this, and this is not 24 karat gold if you watch my last video. Okay, here are the bores for so technically, usually when we cut the jaws, right, we can cut the jaw like this. Okay, it's gonna have, like, if you would actually kind of see it from this point of view, right, it would have a nice kind of radius, and let's call this a radius 3 inches. And if you've seen from my previous videos, I have these numbers. If I'll punch, let's say 3 inches over here, so when I get a 3-inch part, that 3-inch part is gonna perfectly grab it all around, right? These are outer jaws. Let me, what do you call it? I need to get something that's a little bit round. Give me a second. So the importance of grabbing something on a full radius, it's massive, because it's able to hold part when you're drilling, when you boring and other things. And obviously, if you're given a especially pretty hefty cut, you need to kind of hold a pretty good grip on the part, especially on this size. Well, imagine this, the difference between, how you're gonna have a bad grab. If you fully grab it like this is gonna be a maximum grab, right? If you hold it like this, obviously this is easy to kind of pull out, and if you hold it about in the middle, same thing as, you don't really have that good of a hold. So that's why when you make jaws for 3 inches, sometimes, what do you call it? You have a part and you bring a jaw, right? And you kind of try to, put on a part and see if it's gonna be like this. Sometimes it can look like this. Luckily, most of you gonna have a hydraulic jaws, so the jaws are constantly putting pressure on the material. But it happens, and I've seen it happen too, where the part kind of flew out of the jaws. Not enough pressure, or just not enough hold. Even with the hard jaws, actually, it happened to me where the part actually got pushed in when I was drilling. That's why I find it very important to find jaws that will fully grip the part. Each time you're gonna do this, right? So you have only 2 points holding, or you don't have, or the jaws are just kind of too big, right? And it holds in the middle. I think when it holds in the middle, it's a little bit better, but the same thing, it's, you know. Now, if you have, for example, jaws that, let's say, look from the side, right? These are your jaws, for example, and this is gonna be your part. Your part sticks out, maybe double or triple what you're holding. Sometimes it's not a problem. Same thing as if you don't use a massive drill, you're using a smaller drill, there's not that much pressure, right? But the rule is, and I know there's like a formula that, like with, for example, if you hold 1 inch and you have 3 times of that, you know, sticking out, that's still pretty solid. Then 4 or 5 or 6, for example, you hold 1 inch and you sticking out 6 inch out of the, you know, that's obviously getting a little bit riskier. I don't use none of these formulas. I kind of go by the experience, where I know how far I can push my lug, and like I said, and so far I've been lucky, but what do you call it? But I do pay attention, especially if I'm drilling or something, and because I did have it happen to me where the part actually shifted, but I stopped the machine right away. Now, this is kind of like a trick. So, for example, there are instances where you don't have a lot of holding. So let's say, you know, here are the jaws, right? Here's your part. Let's say this is your material. It's sticking out too far, and you have to cut it this much. Okay. Now, if you are to do that, and now you have a part that's very, very slim, and it's pulling very, very far, if you're gonna try to run the finish on this, it's gonna chatter because there's not enough integrity in the material. It's just the material is way too thin and way too long. Sometimes what I do is, technically, I cut this in sections. Depends on the length, but for example, I'm gonna do one section here, right? I'm gonna finish this and I'm done. Then I'm gonna do a second section. Okay, and technically when I do these second sections, you know, let's say this is, you know, 0, this is 1 inch, and let's call this 3 inches, right? So technically over here, let's say you got over here will be 4 inches. So what I'll do is I'm gonna cut from 0 to 1 inch, okay? And then I'm gonna finish this, and then I'm making another bar out unit, okay? And I'm gonna cut it from 1 inch to 2 inches, but I'm actually gonna give myself, instead of 1 inch, I'll give myself start to cut from, let's say, 0.8. So I have about 200,000 room. And let's say if this diameter would be 1 inch, right? I would start my X, and I'm talking about this is finish, not cutting material. So finish from, let's say, 1.003, right? So 3,000 higher. My starting point would be X. Then I would run it to 1 inch. And then depends on the radius of your insert. But let's say if you have a 32 insert, then I would come into, if it's 1 inch, so I would probably come into, let's say, 965. Okay, so technically what you're doing is you're starting up in the air a little bit, then you're coming right to the that finishing section, about 5,000 within it, and then you run and finish of this, and then you come out. And same thing over here, right? You come down under a taper, like I said, usually 3,000 taper, it's plenty, and then it blends into the material, and then you finish this section. So technically you have nicely finished section with no chatter. Just kind of break it into sections, because obviously if you have a large material here and you only have 1 inch over here, then you have enough technically material just to kind of keep it pretty balanced. So this is one of the things. I know it's like you have to create multiple units, but trust me, it beats the hell out of, if this is gonna start to chatter and you gotta finish it, it's gonna look like shit, because you're gonna spend more time trying to polish it or maybe even recut it if you're lucky, if you actually have enough tolerance, right? So now another trick, and this is so usually at my job, at my work, when they cut me material, right, and this is a slug, for example, they grind these corners down. So they actually put the parts on the grinder and they kind of grind it down. If they don't, I use a hand file. I'll go around the corners and technically knock out the corners. And why that is important? Because if you're gonna look at your jaws, for example, so this is a jaw right here, right? Let's make it look pretty. So kind of it's visible. You're gonna have, it depends how you cut it, but if you're gonna cut your, I mean, I wouldn't cut it with a 32,000, but if you're gonna cut it with 7,000, you still have that little kind of side. And if you have a part that's gonna have a sharp corner, that radius will actually push it out a little bit. So what happens when you close the jaws, this radius will push it out, and that part is not gonna sit flush on this face. And this face is also very important because, for example, if you put a lot of pressure down over here, the part, when it's pushing down, it's also pushing down on the face of the jaw. So if your jaws are sitting well on your face as well, that will kind of give it a little bit, like I said, it gives it a lot of holding. So what I would do, that's why you either break this corner, right, so it doesn't sit on here, or you can bring your grooving tool or 35-degree tool and make yourself an undercut, okay? So if, like I said, if you have a jaw like this and you do an undercut, for example, then you can have your sharp corners because it's, you know, because it's not gonna bother it. It's still gonna sit on the face. So either do undercut or break the edges on your part. And so what we did was we were talking about step jaws. The step jaws is because you technically have a step over here, and that works as your stop for this part. But as you've seen on my last video, sometimes we also have a jaws through, right? So you have a, you know, jaw over here, a little radius. Okay, and whatnot. Okay, and so okay, that looks like shit, but you guys know what I'm talking about here. So these are usually, for example, if you so my chuck has a 3 inches and about 0.62 spindle open. So that means if I got a 3-inch part, I can push that part into the spindle and go all the way back in, about 40 inches. When I do bar jobs, sometimes, so I can do bar jobs where all I do have to is pull it out or use a bar puller, and I can run 20, 30 pieces out of each bar. Technically, that would be a bar. If you have smaller or single pieces and whatnot, this is what you call slugs. So slugs in a bar job. Sometimes, you know, you can have, for example, longer pieces. I think that was the one where I loaded the bar guide. So technically bar guide is, if my chuck is, if my spindle inside was 3 inches, I think I cut them down. I make them at 2.9, right? So technically originally, all I did was, I think 3-inch aluminum stock. I made him about, I'm guessing about 3 inches, 3 to 3.5 inches. So like this. You can order these O-rings. I cannot tell you from where, but I remember like I ordered these O-rings. I made these grooves over here, right? On this side, on this side. So I made a groove. I put these O-rings in, and I push them into the spindle where they're like, when they're sitting really, really good. So you can push these inside of the spindle. Okay. And technically, if you have your chuck over here, right, and you can drill these, let's say 1 inch, and I'll probably make it like 1 inch and 10,000 or 1 inch 5,000. If you have a 1 inch bar, you're gonna run this bar through this, okay? So technically this bar guide will support that 1 inch shaft or whatever you're doing inside of a chuck. Because if your part sticks out 2-3 inches and you're gonna have a long ass part inside of a spindle, that's not gonna hold. What's gonna happen is sometimes it's gonna start wobbling inside and all. I've seen there's companies, they make these bushings with inserts made out of polyurethane. But like I said, if you got some 300 aluminum stock and you got a little bit of time, you can probably create these for yourself. And same things for these jaws, you know, it's what do you call it? When you run these jaws, so these will be through jaws, like I said, they're gonna run through them. I have a spindle stop, so technically at the end of the spindle, there's a plate with 3 bolts. That's where originally you had the plate at the collector. There's a collet system. It takes ER32s, from what I remember, with the wrench, and you got this shaft that runs pretty much all the way to the almost front of the chuck, and then you have this bearing system, and then you have this cup that looks like this, and this cup also has these rubber bearings, but it actually spins. So technically this stays all tied up with the chuck, and this thing actually spins, so it doesn't cause problems within the collet. What's really great about that stopper is that you walk to the back of your chuck, you take a wrench, you unlock this, you can push it, pull it, technically it takes you about a half a minute to make an adjustment on your stopper. So when you work usually with long parts and you need to have a stopper in the back of inside of your spindle, these are much better. The company bought it for me about 2 years ago. They're about $1,200. And we tried the tubes that you screw in the sections and you kind of screw it to the, you have that, what do you call it? That, like this triangle plate, right? And you got 1, 2, 3 screws, and you can screw this, pick it up, and then you put in that tube with bunch of extensions, for example, and then you have like a 1 inch rod inside that with a locking knot, and like to unscrew it, it's just a pain in the ass. And like I said, and then I used another one that you just put it in and you twist it and locks in with the spindles, but like by expanding these 3 pegs. The problem is when you're closing the jaws, the whole inner tube moves and your part is also going to shift. So versus this one stays in because the inside cylinder, it will slip on this, and your Z point is not affected. So my problem with all these others, it's just took too long. That's number one. The Roe V1 just kept shifting with the part. I couldn't hold my Z. Sometimes I would see like 5,000-10,000 variation, which obviously if you're working with 1,000 and less tolerances, this is technically unacceptable. I'll make a video on this one. I'll take it apart. If you're a shop owner, or like I said, I think this is a very, very good equipment to kind of invest in, because if you do a lot of setups, this will save you a lot of money. It will pay itself off literally within 2-3 months. So like I said, point of contact, remember that. If you're holding by 1 inch, at 5 inches, I would start questioning the integrity. Sometimes if you're not sure how well it holds, especially if you got big drills coming in or you want to do a big cut. If you have like a nice rubber mallet, like a large plastic hammer and whatnot. Okay, so this is your part, right? These are your jaws. Put your indicator over here. Okay, so your needle is touching it. Then what I would do is bring the indicator. So for example, watch on your clock, for example, if you're gonna watch your position machine, if you touch it at 1 inch, okay, then bring it up so you don't damage your what do you call it? Let's say, by the way, indicator, let's say it's gonna show you 10,000, right? 0.010. And then bring it up and just smack it with the hammer. Then bring it down to 1 inch and see if it's gonna stay at 10 or if it actually moved a lot. If it moved a lot, then I would probably change my setup a little bit. I've done this before, like I said, when I start working on these machines, because I wasn't sure if I got enough holding. But I've done this before, and if it would shift a lot, then I figured there's a risk. If you enter with the 1.5 or 2 inch drill, this part might shift. And if it's gonna shift, you technically might actually crash the machine, or you could put your machine out of its center. So, all right guys, this is long enough. I hope you enjoyed the Chuck Norris, and thank you.